All right, so this is a suggested book problem, number 98 from chapter 1. And this is a really great problem, and it's pretty difficult. There's a lot going on in this problem, so I'm going to walk through it. This was a requested video, so thank you to the person who requested it. So in this problem, the first thing I always want to do is sort of organize the information that's given. The first thing that we're told is that we've got a graduated cylinder. So this is what a graduated cylinder sort of looks like. And we're told that the empty mass of the graduated cylinder is 124.966 grams. And when we fill it up with 40 milliliters of mineral oil, that the mass of the oil, so mass of oil plus cylinder equals 159.446 grams. So using these two numbers, right away we can figure out, well, how much does the oil weigh, right? So when we add in the mineral oil, the difference between these two numbers is going to tell us that we have added 34.48 grams of mineral oil. So initially, right, I'm just sort of taking the information that's given and sort of figuring out, well, what can I figure out from this? Like what is this telling me? What are some aspects of this? So right away, this is the mass of the empty cylinder. If this is the mass of the cylinder plus the oil, and I know how much oil we put in, then I can actually solve for the density of oil. So at this point, I'm not really trying to necessarily think about what the question is ultimately asking. We'll get to that later on. I'm just sort of taking the information that's given and figuring out, well, what does this tell me? What can I figure out from this information? So the density is going to be the mass of the oil divided by the volume. And if I know that this is the mass that we put in and this is the volume, then I can solve for that density of oil, which is 0.862 grams per milliliter. So this is the density of my mineral oil. And then the next part of the question says, well, we're going to put in a little ball, I forget exactly what they call it in your textbook, but basically you put in a little metal ball, and then you fill this back up with mineral oil. So the information about the ball, it tells us that the mass of the ball equals 18.713 grams. And when we add mineral oil, we're told that the mass of the oil plus the mass of the ball equals 50.952 grams. So basically what it's telling us is that we did this first experiment. Now experiment number 2, we're going to add the ball in first and then fill it all the way up with mineral oil. Now we can, weigh what happens, on the scale. The mass of the ball by itself is 18.713 grams, and then the mass of added oil to get back up to that 40 milliliter mark is going to be, plus the mass of the ball equals 50.92. So from this information, we can figure out the mass of added oil. So the difference between these two numbers should be the mass of the added oil, which is 32.239 grams. Okay, so now here's where we need to start sort of taking the information and ultimately moving towards solving this problem. So if this is the mass of the added oil in experiment 2, we can use the density that we solved in part 1 to figure out what the volume of the added oil is, right? If we know the density of the oil, we know the mass that we added in a different experiment, we can use that information to solve for the volume of oil. So the volume of oil added, that's going to be 32.239 grams. And I'm going to use this density as a conversion factor. So I know that 1 milliliter of that oil weighs 0.862 grams. My units of grams will cancel out, and I will end up with 37.400 milliliters as my volume of oil. That's the volume of oil that I added on top of that ball. If I know that I add to the 40 milliliter mark, well, now I can solve for the volume of the ball. And that volume of the ball is going to be 40.00 milliliters minus 37.40 milliliters, and I can solve for that volume of ball as 2.60 milliliters. So that is the volume of this ball because we put the ball in, then we fill it up with mineral oil. We now know the volume of mineral oil that we added, and we know that the total volume needs to equal 40 milliliters because we filled up to that 40 milliliter mark. The last step of this problem is really just sort of testing your math skills. It tells us to solve for the radius of the ball. I know that 2.60 milliliters is the same as 2.60 centimeters cubed, and that the volume of a sphere is 4/3 pi r cubed. Using this equation, I can solve for the radius. The radius of this ball should be 0.853 centimeters. So that is my final answer, and that's the answer that you should find in the back of the book. So if you have any questions about this process, it's definitely a difficult problem. Let me know, and I will hopefully address those for you. Not hopefully, I will. All right.